play Family Feud. No, it's time to do boring math. I'm sorry, guys. Yeah, we didn't have the budget for Family Feud, so they kind of hired me to do this instead. Hi, my name is Fedora. I am going to be teaching you guys lesson 5.4, medians and altitudes. Now, before I start teaching you guys this, I want to tell you about two things we're going to be learning that they have in common is points of concurrency. We are going to be learning about orthocenters and centroids. A point of concurrency is when three or more lines connect at one specific point. Now, when you do this, the orthocenter will be used for altitudes, and it has to do with perpendicular bisectors, while the centroid is used for medians because it has to do with the lines connecting to the medians. Okay, now for the beginning lesson of medians. Medians. Y'all can see that, you know. So, a median is the distance from the vertex, right? Which is a point on any shape, triangle, square, etc., to the midpoint of the opposite line. So, for example, triangle ABC, right? For triangle ABC, point A is the vertex. Now, in between C and B will be D, and that would be the midpoint of this. And now this line is what you would call your median. Okay, are you guys with me? Are you guys with me?
Yes, teacher.
Okay, good. Because you know y'all lazy bums don't do nothing, don't pay attention in class. Okay, so I'm going to draw the other midpoints for the other things now. Okay, so C corresponds to E now. And keep in mind, these are all medians. And, okay, B corresponds to F. This point right here is the point of concurrency, which is the centroid, right? And I'll label that centroid. Centroid. Now, when you are doing things like this, you do know that these are congruent to each other. These points are congruent to each other, and these points are congruent to each other. Don't know why I have 4 lines here. Now, when you do this, there is something you need to know. The distance from a vertex to the point of concurrency, or the centroid, is the 2/3 of the distance of the vertex to the midpoint. So, for example, in this one, let's name the centroid G. AG is equal to 2/3 AD. And because that is true, then GD is equal to 1/3 of the total AD, and so on and so forth. So CD is equal to 2/3 CE, BG. Oh, why? CD. CG, sorry guys. BG is equal to 2/3 BF. Now that you know this is basically all I'm going to be teaching you about medians. Okay, now this medians. Now I'm going to be teaching you guys about altitudes.
Teacher, what's an altitude?
An altitude, thank you for asking, young sir, is the perpendicular segment or line that connects a vertex to its opposite side. Now, when you do this, it is shown like this vertex. I'm gonna give you a triangle like this.
Wow.
Yeah. Okay. This vertex, and to make this perpendicular to it, you would. That is a perpendicular line. Now, that is the altitude of this triangle. When you are doing altitudes, they have a point of concurrency, and that is called the orthocenter. Now, centroid and then orthocenter, I will not show you this one. Now, for an acute triangle, when you do an acute triangle, it is shown like this, right? Where the points of concurrency are actually inside of the triangle. So when you do it, it is and this is the orthocenter. Now for a triangle, stop playing around too much. Okay, this is now for a right triangle. The point of concurrency is going to be on the triangle instead of inside the triangle. Because when you draw a right triangle, the points will actually be two of the legs instead of the hypotenuse. You will see two of the legs. If you do it this way, this, the perpendicular to this, would be its own line, and perpendicular from this vertex to this line would also be its own line. So now you have those, and then here the perpendicular from this vertex to it would be here. Now when you do that, this is the orthocenter. And then our third and final triangle is an obtuse triangle, right? And when you do an obtuse triangle, you will see that the orthocenter is outside of the triangle itself. So when you draw the triangle, you draw it like this, right? Okay. Draw a triangle like this, and the points will correspond in this way. Perpendicular from here to its opposite will be this line here, and perpendicular from there to its opposite will actually be, from this vertex to its opposite, will actually be a line outside, which is extends here, and then same thing goes for here, it extends. Now, you see that they don't connect off the bat, and what you do to allow them to connect is, you kind of just make it connect better. And then that is it. So the point of concurrency here would be the orthocenter. Okay. All right, so when we're doing this, we also need to know about isosceles triangles, because you see there are three triangles here except for isosceles triangles. And the thing about the isosceles triangles is the fact that all of the bisectors, which is perpendicular bisector, angle bisector, and also the median is all going to be the same, well, also altitude actually. It's all going to be the same exact line, no matter what, because the triangle is isosceles. So that will be seen later on in one of my practice problems. Okay, there was a slight change of scenery because we got kicked out of our last space. But I will be showing you guys the problems for 5.4. The problems, I'm going to be putting a problem up right now. I already set it up. This is the centroid, and the centroid will be labeled G. So, G is the centroid of triangle ABC, right? And BG is equal to 6, and AF is equal to 12, and then AE is equal to 15. Okay. Now, you have to find the lengths of the following segments. And these segments include FC, C, and because we already know that AF is 12, BG is 6, AE, the whole thing is 15. Since we already know that AF is 12, F being the midpoint, since G is the centroid, you know F is the midpoint of line segment AC. That means that FC is also equal to 12. Now, to find AG, you have to do a little bit more math. AG is the vertex to the centroid, and that is 2/3 of AE. And that is, if you do the math, that's 2/3 of 15, which is equal to 10. And then now you also have to find BF. BF, this is a BF, BG is equal to 2/3 BF. I like to write the equation down first. That means when you substitute 6 is equal to 2/3 F. BF is equal to 3/2 of 6, which is 1.5 times 6, right? And the answer is 9. Yes. That's the answers for these parts. Here's the math. Give you guys a second to comprehend. Alright. Okay, so I finished writing the problem down. Now, with this problem, you see that M is the centroid of triangle ACT, S, Q, and R are the midpoints. I know this is not drawn to scale, but keep in mind. Now you are trying to find AM, which is here. AM is equal to 2/3 of the whole entire segment, which is equal to AQ. Now, knowing that AM is equal to 2/3 of AQ, you also know that MQ, which is the thing that is given to you, is actually 1/3. Q is equal to 1/3 AQ, with the math done. Now, you don't have to use all of these numbers, but all you really need is MQ. Now, when you do this, MQ is 30. 30 is equal to 1/3 AQ, and when you do the math, AQ is equal to 3 times 30, which is equal to 90. Now, you have to complete the original equation, which is AM is equal to 2/3 AQ. AM now has to equal to 2/3 90, and that answer is 60. So that gives you the given value of AM. And I'm going to move out the way so you can look at the problem. Now, for this one, I made a giant dot here so you can indicate T. This person thinks that because T is a point of concurrency, that the segment MT is equal to 2/3 MS. Now, you have to explain why this is incorrect. The reason this is incorrect is because even though you know this is a point of concurrency, there are 4 different points of concurrency. There's the centroid, the in-center, the the orthocenter, and there is another one which I have forgotten at the moment. Now, all the given information that you have is that these create perpendicular lines from the vertex to one of the segments on the line opposite to it. Now, you do not know, it is not given to you whether any of the points are the midpoints of the line opposite to it. So, based on this information, you can only tell that this is the orthocenter, so you are not going to be able to find if it's 2/3 of the whole, because that is for centroid. Now, if it were to give you that MR is congruent to RN and everything, if it told you that these were specifically the midpoints, then yes, you can argue that it would be correct. But because it doesn't give you that information, then it, by reasoning, isn't correct. And I'll just do final two problems I am going to have for you today, and I'm going to give it up to my friend Patzy over there. So this last problem, it gives you a triangle XYZ, and it gives you line YW. Now you have to find if it is a perpendicular bisector, an angle bisector, a median, or an altitude of said triangle. Now the information you are given is that YW is perpendicular to XZ. Now, with that information, you already know that it's a perpendicular bisector. So that is correct. So it is perpendicular bisector. Now, you also, now knowing that it's perpendicular, you also know that XW is congruent to WZ, and YW is congruent to itself based on reflexive property of congruence. Knowing this information, based on side-side-side congruence theorem, you know that XY is congruent to, ZY, and that means that the triangle is an isosceles triangle, because these two are congruent to each other, and then that one base. Now, knowing that it is an isosceles triangle, you know that all of these apply because, as I told you in the beginning, with an isosceles triangle, that line is the median along with the altitude, along with the perpendicular bisector and the angle bisector. So, yeah. Now, for our last and final problem, you have point D is a centroid of triangle ABC. Use the given information to find the value of X. Now I'm going to draw this triangle for you because it is better to have a representation. Now, F and then C to D. Now they meet at point D. Now, you know that BD, which is this distance, is 4x plus 5, and then BF, which is the total distance, is 9x. With this information, you can write said equation like this. BD is always going to be equal to 2/3 BF. Now, when you convert and you plug in all the information, that means 4x plus 5 is equal to 2/3 9x. And now we're going to take it a step further. Now, you take the 2/3 away to leave 9x by itself as the sole variable of this. So that means 3/2, or 1.5 times 4x plus 5 is equal to 9x. And when you do this, you get 6x plus 7.5 is equal to 9x. Now, to get 7.5 alone, you subtract 6x from 9x, which means 7.5 is equal to 3x, and to get x variable alone, 7.5 over 3 will give you x. Now that means x is equal to 2.5. And when you check this answer, you should get the same thing, because 4 times 2.5 plus 5 is equal to 15, and then 9x is equal to 22.5. So 15 is equal to 2/3, 22.5, and when you do that, that is correct. Now, for this, it gives you AD is equal to 5x and DE is equal to 3x minus 2. Now, something tricky about this is that it gives you AD and DE, but it doesn't give you the total. So, with all the information you know, AD plus DE is equal to AE. Now, with this information, you can do the following equation. Alright, so the last problem is AD is equal to 5x and DE is equal to 3x minus 2. Now, using the same thing, AD and DE gives you the whole value of AE. And that means that AD is equal to AD plus, 2/3 AD plus DE. And to plug in the variables, 5x is equal to 2/3, and you combine like terms here, 8x minus 2. Now, to find the value of x, you do 3 over 2 times 5x is equal to 8x minus 2. 3 over 2 times 5x is equal to 7.5x is equal to 8x minus 2. And to get 2 by itself, you divide 7.5x over 8. And then, well, not divide, but subtract, because it's 8x minus 2. You do 7.5 minus 8x is equal to negative 0.5x is equal to negative 2. Now to get x by itself, you do negative 2 over negative 0.5, and that gives you the answer of 4. Now when you plug this in, you should be able to get the same exact answers. And that is all I have for you today. This is finding medians and altitudes.
Okay, so this is Patzy here, and the following video, Jahmier is going to do copyright stuff, and please don't sue him, an account of Khan Academy. Anyway, this is 5.5, use inequalities in a triangle. It's actually pretty simple. So basically, when you see the smallest angle, the opposite side of the smallest angle would be the smallest side, and for the largest angle, the opposite of the largest angle would be the largest side. Similarly, the largest side, opposite largest angle, smallest side, opposite smallest angle. Another thing we learned is the length of any two sides of the triangle is greater than the third side.
Next slide.
Where is the next slide? Here it is. So these are problems for 5.5. Number 1, basically to write the order of the sides in angles from smallest to largest. So this side, KL, they give you the sides. KL is 13, LJ is 25, and JK is 28. So the smallest would be obviously 13. So sides, the smallest one would be 13, which is KL. And then the largest one would be 28, which is JK. Just kidding. And then obviously the medium one would be LJ, 25. Now for the sides, would be the opposite. So KL 13. The opposite of this would be side J, the middle one, LJ, 25. The opposite of this would be K, and JK, the opposite of this would be side L. Now for number 2, this problem is wrong, and we have to find out why. So in a triangle, there is 180 degrees, correct? So this angle is 59 degrees. minus 59. 1, so the 6, 1. So 121 degrees would be the addition of this angle and this angle. So these aren't equilateral because of the other side, which means that this would be 17, basically both sides. So now if you do 121 divided by 2, it's minus 12, 10, would be basically 60.5 degrees. One of them has to be at least 60.5 degrees. However, the opposite of the largest angle has to be the largest side, since these two are equal. But the largest side is 17 on the angle 59, which means that this is wrong.
What you doing, Fedora?
Anyway, okay, back. Okay, for number 3, we have to find all the possible values of x. So as we know before, that two sides added will always be larger than the third side. So let's go on that. So here, just writing the problem down using these two sides would have to be larger than the third one, this one. So x plus 5x equals 6x. That 6 is ugly, please ignore it. And 11 minus 9 equals 2, which is greater than 2x plus 10. Minus, so put everything of the same value on the same side. That is 4x plus 2 is greater than 10. 4x is greater than 8 divided by 4. X is greater than 4. Wait, math is horrible too. So we did those sides, so now let's do these two sides. So 5x minus 9 plus 2x plus 10 is greater than x plus 11. So 5x plus 2x equals 7x, 9x, minus 9, negative 9 plus 10 equals plus 1 is greater than x plus 11. That would equal 6x is greater than 10. So x is greater than 10 over 6, or 5 over 3, or basically 1 point, that 1.6 repeating. And the third one would be adding these two sides are greater than this. So x plus 11 plus 2x plus 10 is greater than 5x minus 9. 2x plus x equals 3x. 11 plus 10 equals 21 is greater than 5x minus 9. So that 3 looks like a 5. Anyway, so we subtract this. I kind of like not having negative numbers, so I'm going to do the opposite. So 5 minus 3x would be 2x, and then 21 plus 9 would be 30. So you divide this by 2, and 15 is greater than x. So now to solve this, the answer of what the possible values of x would be. Well, we have that x has to be greater than 5/3. X also has to be greater than 2, and x has to be less than 15. Since this is greater, 2 is greater than the 5/3, that means that x has to be greater than 2, but it has to be less than 15. So 15 is greater than x and less than 2. Thanks guys for watching. Next is Jahmier.
Hello and welcome to another Khan Academy. Actually, no. Let's change that. Welcome to another Geo Academy tutorial. And today we're talking about the hinge theorem in 5.6 in the geometry textbook. And it's kind of like a gate, but I'll get to that later. The hinge theorem basically states that if you have two different triangles where two of their sides are congruent, say these two sides are congruent, the angles will determine the length of the furthest length that is not congruent. So say this angle right here is around 30 degrees, this angle right here, and we'll say that this angle is 78 degrees. Then, based off of the theorem, this side length will be greater than this side length over here. Now, with almost every theorem, there is usually a converse theorem. Now, the converse of the hinge theorem is just like before. If two different triangles have two congruent side lengths, instead of the angle determining while the length of the side length, if these two triangles are congruent, let's assume they're both congruent, and this is 5, which means that this would be 5. If you change the distance of this to say 10, what that would do is it would first off extend this length, and which would make the angle become wider. And now this angle is wider than it was before. The reason why I compared it to a gate earlier is because, like a gate, if the gate were to open larger, it would change the angle of C. I'm sorry, it would change the angle of A. See here, A is larger than the angle here. So let's call these, let's call them B prime, A prime, and C prime to lessen confusion. A is the larger angle than A prime, which means that line BC is greater than line B prime and C prime. This is an example of a gate, just to, make it easier to follow through with. Okay, the second part of this 5.6 is indirect reasoning for Geo Academy. Copyright. Because I don't want nobody stealing my idea for this. This is all me. And basically, indirect reasoning is another way to prove that something is correct. And to do so, there are 4 steps. The first step is to identify. And basically, what you do is identify the statement you want to prove. After that is to assume. And you assume temporarily that the statement is false by assuming the opposite is true. After that, there is the reason, and you need to reason logically until you reach a contradiction. And then last, you have to point out that the desired contradiction must be true because it proves the temporary assumption false. And after you follow these 4 steps, you will be able to finish your proof. We have a problem. If x and y are odd integers, then xy is odd. And to this, we're you to use an indirect reasoning. So, first step is to identify what we need to prove. We need to prove that, as stated before the question, that x and y are odd and that xy is odd when multiplied together. And now we need to assume the opposite is true. So we need to assume that when you do x times y, it equals an even number. And to prove this, to reason logically, it would basically be x needs to be divisible by 2 and y has to be divisible by 2. Now, and it turns into an integer. And since x is odd and y is odd, that means this cannot be true. Okay, for example, if x was, say, 3, y was 7. Together, that equals 21. And it goes to the thing that we said over here, that if 3 were to be divisible by 2, and 7 were to be divisible by 2, this would then equal 1.5, not an integer, and this would be 3.5. And since it being even is not true, then that proves that in the end, x is y equals an odd answer.
Okay, got it.
Fedora, I'm all the way.
I'm 5.4.
5.5.
And I'm 5.6. And that's
Mathematical.
That was
the best ending I've ever seen.